It's 2:15 a.m. Production is running. No alarms, no shutdowns. If you look at throughput and yield, everything looks great. But on this system that we're watching, this is a tobacco plant, and quality is king. And the quality of the product is rapidly decreasing, and the defect rate is starting to trend upwards. I'm going to show you an end-to-end scenario today that shows how TDengine's IDMP is the most powerful way to get control of an end-to-end operation, showing this real-life tobacco example. So, what do we start with? This quality overview tracks defect rate, scrap rate percentage, yield percentage, throughputs, and it shows us the throughput is stable, yield hasn't dropped, but the defect rate is increasing. And this tells us the most important view because it tells us the defect rate is increasing, and from an OE perspective, the quality here is tied directly to the scrap. So as the scrap increases, the quality immediately decreases, which we could see here. So what does that mean for us? It's the first measurable signal of unsellable product. Now let's move to the control command center of line performance command center. So here we can look at three key metrics: temperature and moisture and humidity. Temperature is gradually dropping below its optimal range. Not a spike, not a failure, just a sustained deviation. And we've defined an analysis that captures this to show you what IDMP can really do. But let's talk about what temperature actually means. Temperature doesn't set moisture, it controls how well the system regulates it. As temperature drops, the system becomes less effective at stabilizing moisture. Control over the material also starts to weaken. Now we look at the moisture percentage, right? And moisture is increasing during the window. So it's not a drying issue, this is a loss of moisture control. Now let me show you how IDMP can help. Going back to the Explorer, we can see how IDMP connects the end-to-end process. As you can see, the tobacco plant has process, making, environment, and devices. And each one of those have individual elements underneath it, end to end. Now going into the direct process, you could see that I can control everything from one place, and that's what IDMP provides. But we can go one level deeper. Going into panels, we have one for moisture, temperature, and quality, which I'm going to click on right over here. Now clicking on this panel, you could see how these three attributes connect, right? So right here, you could see the quality of the product declining as the moisture increases. Also, the temperature is inversely correlated to that. So now I can kind of get to see that overall picture. Here's the full chain. Temperature drops, system loses moisture control, moisture rises beyond an optimal range, material becomes inconsistent, the defect rate goes sky high, and the quality decreases, as you can see shown here. Now, I've analyzed it with my eyes, but I want even deeper analysis, so I'm going to go to AI for that. The LLM integrations of TDengine provide rich context on your data, and right here, it shows that it demonstrates a moisture quality dependency, with temperature acting as a significant factor. So, right here, we know exactly what we can change and what our actionable item is. So what do I do as a next step? First, I need to understand why moisture hurts the quality. When the moisture gets too high, the material becomes too soft, density becomes inconsistent, and product formation becomes unstable. That shows up in other metrics like defects and scrap. Now, we take this, we know what controls the moisture, the temperature, because it controls that evaporation rate. We need to go find out when the temperature drops so the moisture doesn't increase. I've already set up an analysis here that triggers an event when the temperature drops too low. That's one of the first things you can do in TDengine. You can track in real time the temperature, right? So here we can know the temperature deviation and then fire events for it, which I fired over here. We could also analyze when the temperature has dropped. And these are a couple of events thrown on. It shows you exactly when the temperature has dropped. Now, that's one powerful thing. And now that we found the root cause, this is our actionable insight. This is exactly what we're going to do and take to the next phase to change our operation. But what if I want to predict what's happening? I can also do that. So I've already set this up. Knowing how crucial moisture is, I want to project that moisture, right? I want to show that moisture in real time, which I can do. So here I'm projecting what the moisture is going to be coming up, and now I'm able to track in real time what's happening and also project what's going to happen. And I can get insights on top of this projection. The insights tell you what the data is showing currently. And using my knowledge as well as the AI's knowledge and including the projections allows me to paint the whole picture. Now I can do things like monitor for what's going to happen, track what is happening, all on the same system. End to end, IDMP is the most powerful tool on the market to do all of these things. Thank you.